Now here I'm going to show both ways of calculating this, and we're going to get the exact same answer. This is a growth problem. The population in Sorrentinoville is increasing by 15% every 8 years. How long will it take for the population to triple in size? So again, they don't tell us how many people are in Sorrentinoville. All I know is it's increasing 15% every 8 years. So I'm going to take that information. Now, if I'm using the first formula we would worked with, I need to find A first. And also, I want to keep a note that if I'm increasing by 15%, the population will be 115% of what it was. So I remember that particularly when I write p in terms of p sub 0, I'm expecting to have an amount that's bigger. If I just put 0.15 p sub 0 for p, I'm saying that's 15% of what it was before. So I want to find a, so 1.15 p sub 0 would equal p sub 0 times a to the 8th power. Again, I'm just substituting a 8 in for t, and I'm substituting 1.15 p sub 0 in for p because that would be the final amount after 8 years, 115% of the starting amount. So, because basically it means I'm going to have the starting amount I had plus 15% more, so that's 115%. So I have a to the 8th power equal 1.15, which means a would be the 8th root of that, which is about 1.0176. Still in line for what we're talking about here, because remember what we talked about, if I'm using this kind of format and I have a growth, a should be more than 1, and it is. So my formula is now this. I'm showing 4 decimal places for that, but I am keeping all the numbers stored in my calculator's memory when I do this, so that you know, if you would get a slightly different answer and because all you're typing is those 4 decimal places, you'll know why the answers might be off a little bit because I'm still using all of them. I'm just writing down 4. To triple in size means I'm going to have 3 times the original amount. So my final amount is going to be 3 times p sub 0. Again, I'm going to divide both sides by p sub 0. And also using the symmetric property of equality, 1.0176 to the t power would equal 3. I can apply natural logs of both sides, and therefore on the left I could also bring that t in front and make it a multiplication. And so t is going to be the natural log 3 over the natural log of 1.0176. Just as a side note, I could have also just said, well, when I was at this step up here, if I could show it right here, when I was at this step right here, I could have also said, to go to the next step, I could have said that the log base 1.0176 of 3 equals t. Well, then I would use my change of base formula, and I would still get something of the line natural log 3 over natural log 1.0176, or log 3 over log 1.0176. You still get the same amount. Doesn't matter. One of the good things about using the second formula is that, here I could choose to use natural logs, or I could use any other log I want. Whereas if I do the second one, it'd be silly to use anything but the natural log. But let's go through the process here. How would I do that with this problem? Now, the only thing that's going to be different here is that, I'm still going to, in the first part, I'm still going to assume that I have 115% of my original amount after 8 years. Now, the only thing that's different is I'm going to be finding k, not a. So I'm going to have 1.15 p sub 0 equals p sub 0 times e to the k times 8, which means e to the 8k is 1.15. I would natural log both sides to get that 8k equals natural log of 1.15, which means k would be the natural log of 1.15 over 8, which is about 0.01747. Which is good for me because that still indicates a growth because k is positive. If k is negative, that would indicate a decay. So my formula that I'll be using is going to be p equals p sub 0 e to the 0.01747t. Now, as a side note to this, if you would actually do e to the 0.01747, you would get about 1.0176, what we had in the previous one. So that's why it doesn't matter so much. But I mean, the only thing that's different here is that we are forcing an exponential base of e, whereas in the other one we were allowing any exponential base to be used whatsoever. But it's going to be the same thing. I'm going to triple in size. So I'm going to have 3 times p sub 0 equals p sub 0 e to the 0.01747t. Divide both sides by p sub 0. Natural log both sides. and then divide both sides by 0.01747. And again, 0.01747 is the natural log of 1.0176. And I still get 62.88 years. So it doesn't matter which method you use, you should get the exact same answer each time.